Right. Let's continue with our OCL stuff, and so we still have two more classes. So I'm planning having a maybe review class. Talk a little bit more. I'll talk a little bit about the finals. So what's gonna include in the final, and I'm gonna finish this OCL and talk about those final things next week. So that's a whole plan for. It's a plan for it. So that I'll finish the semester. Yes.
Is the final online?
Yeah, if it's online, it's gonna be open note. Yeah. Okay. And if it's open note, you need to, it should be quite intensive because maybe a lot of questions you need to solve. Basically, for this class, it doesn't make too much difference between the open note and the closed note. Yeah, actually, but actually, if you treat it as a closed note, you will be faster. But yeah.
Is there like a specific time online we take it, or is it like open?
Yeah, it's like Euro. We will have a specific time. It's timed, and I'll make it available in a day or two. For a day or two, and once you start take it, it is going to be timed. Okay.
Do we need to? Can we present our our slides in class, or do we need to post it on the forum?
Yeah, you just need to post it on the forum.
Okay.
And you pick one from the other. Submit the evaluation form. Okay. All right. Okay. So let's continue with this example. All right. So still this loyalty program. We have a little bit refresh a little bit. We have a loyalty program. Each program has different partners. Remember, because one program they can share those points with different manufacturers, different program partners. Delta, another gas station. Okay, a service. So for every partner, they have a different service. Yeah, they can use the service to burn or to earn the points. And when you are using some service, when you are doing some transactions from the member customer has card and it has the transactions to update those points in the loyalty account. And transaction belongs to the transaction. One service can actually have different transactions. It can be like a service of you purchasing a ticket, and the transaction is gonna earn some, help you earn some of the points. Alright, there are some service that burning the ticket, like you use your points to exchange for a ticket, or there's some transaction that does both burning and earning. Okay, so like you use your membership card for some discount. So in this system, it doesn't have those like discount kind of service. The service will always connect with this transaction. So what it does is it puts the earning and burning maybe the same, so that your points remains the same. Okay, for the discount program. Okay, so that's modeled by this system. Of course, you can model another kind of service which is not burning or earning, just a discount. That's up to you. But in this system, it's modeled that way. Okay. All right. And this is a where are we? Body. Okay, so we were here talking about how to add additional information. So this is how we add additional. That's how we initialize the value for some attribute. So here, this is we add in this query operation. We define some query operation for each of the class. Okay, like here, loyalty program. If you look at here, loyalty program, we have this get services. Therefore, if we want to define what this get services did, it actually so this defines where are we. We're standing on the point of getting get service, and it's of the type set. So when we call this function, it returns a set. Okay, okay, this function, it returns a set. And here, body. Body means this query operation, which returns the value. It's the same value that this get service returns. So it will return partner dot delivered services. If you look at here, partners, it's loyalty programs partners services. Okay, so it returns a set of services. That's clear, right? That's clear. Okay, and for this we use this if then else stuff. So kind of put a logic there, so you can have the option with those conditions. So it returns different value with different condition. Okay, it either returns. So this is actually we're extending that with this parameter. We'll want to get the services by a certain program partner. Like I mentioned, one loyalty program can have different partner. Now, for this operation, we're getting the services belongs to some certain partner. Okay, no problem with that. Right. Therefore, it's actually checking if that partner is included here. If it's included, we just return the service. Otherwise, we return an empty set. Okay, we return an empty set. So this is called query operation. Query operation means the operation that won't change any state of the system. It's just maybe pulling the information, maybe counting how many students are there, things like that, counting the numbers, things like that. Okay, it's called query. All right, and also we can use the OCL to defining new attributes and operations. Okay, so like here, loyalty program is only have one. It only have one attribute, name, of the type string. Only two operations. So at some point you think, yeah, I'd like to add some new attributes, and maybe operations. You can do that in OCL as well. So you just need to first navigate to that context. You want to add those attributes and operation. Then you use the keyword define, something like this. So here, let's see if we are in the loyalty account here for this class, loyalty account, which has points number, and you have this operation to earn the point, to burn the point, and check if it's empty. Okay, so now we want to extend this class, this loyalty account class, with an attribute called turnover in this class. This turnover will sum the amount attributes of the transactions on this account. Okay. Yeah. So it basically, this turnover, it sums up all the transactions. It can be negative or positive. Okay, it just sums them up. So kind of like your balance. Okay. Okay. Therefore, it's just an example. Therefore, if we want to do that, it's something like this. First context, we switch to loyalty program, a loyalty account. Loyalty account. And then with this keywords, define, we can define new attributes for this class. Suppose we're trying to define this turnover, and then we need to define the type of that attribute. Remember this, when we define attribute, we need to tell what type is it. If you still remember, we have real instead of float and the double, right? We discussed about this last week, right? So why there's no float or double, but only real there, right? So we have this real defined in this OCL thing. Okay, then we give the value. It's the transactions amount. So that's a set. And then we use this sum operation of the set to add all the transactions together. Okay? To add all the transactions together. So basically that's the points you get from the transactions. All the points you get from all of the transactions. So it will be different from, maybe you think this turnover will be similar to the points here, to the points in loyalty program, right? You may think that's similar, but if you think about because points, it may have an initial value. Okay, so points, actually it equals to the initial value of points plus the turnover. Does that make sense? Does it make sense? So turnover means every activity in these transactions. It's like for the turnover of today, it means I spend $10, maybe I earn $20, so the turnover is $10. Okay, turnover is $10. And if I have a beginning balance today, right? If I have $1 million, so the points is gonna be 1,000,010. Turnover is 10. Okay, makes sense. Yeah. So that is how we define this turnover. All right. But the important thing here is we use the keyword DEF to define. All right. Make sense? Make sense? Hopefully. Yeah. Okay. Next. we can also define operation. Yeah, we can define operation and define new operations, but it has to be a query operation which doesn't change the state. So for example, still in this loyalty program, no, we're now in loyalty program. Okay, we want to introduce the operation get services by level in the class loyalty program. So this returns a set of all delivered service for a certain level in a loyalty program. Let me explain that to you. So we have a loyalty program there. So loyalty program yeah, loyalty program has the program partners. Partners deliver different services. Okay, like I give you discount, I make you have a I give you discount. I can give you a benefit. I can give you a benefit for you purchasing some items. Give you points for every $10 you spend. Something like that. So you deliver those kind of service. Okay, and the service is actually connecting with the service level, which make it something happen. Like if it's a silver level, golden level. Like in the silver level, you get 10 points for $10. In the golden level, you got 20 points for $10. Okay, something like that. Okay, so that's the service that's controlled by the service level. That's why this service is using the information of the service level, because for every service delivered, if it's in different level, your transaction, the data of the transaction earning burning is going to be different. Okay, so that makes sense. Okay, that's fine. Then we want to introduce the operation get service by level for this loyalty program. I want to get every service that is in golden level. Okay, no matter where it comes from, no matter where the service comes from, Delta or gas station. I just want to get the golden level service. Okay, so let's see how we define this operation. We want to define this operation. It's gonna be get service. Let's name it. Name this operation. Get services by level. Okay. And level name, which be a string. Then it actually returns a set, right? A set of service. Right? So we define this first. We define this operation with its parameters. What kind of parameter it's gonna take? It's gonna take a string, and then we define what is the return. What is the return? The type it returns. What it returns? It returns a set of service. Okay. And then we define how can we what we do in this operation. All right. So equal to levels. Remember. Select. If you still remember the function select in the set, it returns a subset of that set which meets some certain condition. That's called select, right? So we want to select name equal to level name. Okay, so that's a subset, and V. Okay, let's look at this here. So it's going to be from the loyalty program, we navigate to the levels, which is here. And the levels, we're going to select the services that with the name equals to golden or something. So it's actually going to the services. Yeah. From this available services, which, so we navigate first through this loyalty program to service level, and then we navigate through the service level to this available services. Okay, so here we first, from this level, from loyalty program, we navigate to levels. Then in the level, we select only the golden level. And then from the golden level, we select all the available services in the golden level. Okay? Make sense? Make sense now? Yeah, we have to look at it with this diagram. So, yeah. Yeah, I need to know if you are maybe confused. I need to know where are you confused, because yeah, so that I can explain that part more. Just bring whatever question you have here. Yeah, it's straightforward, right?
I guess defining the relations between the classes.
Define what?
Defining the relation between the classes.
Define the relation between the classes. Okay. Alright. So between every connected class, there are some relations there. Right? So you can use this kind of relation to navigate through this class to here. Like if this is like customer card, 2 transactions, it's one to many relations. Okay, so if you are going to, so if you navigate through this customer card, which is your current context, if you said customer card dot transactions, it's going to return you all the transactions. So that's a set. Okay, if you are in this transaction and you are going back here, card, it's only going to return you a single object, because that's many to one. Okay, so one transaction will only have belong to one customer card. So if you're in the context of transaction and you're using card relation, okay, you're reaching here. However, you can, this navigation can like continue if you're using dot dot dot. Like you can use the customer card dot transactions, then dot generate by, and dot partner. You can all the way go there. Okay. Okay. Just you need to pay attention to this. If it's one too many, it's gonna return you a set. So if it's a set, and it goes here, if it goes here, then if you go from here to here, it will return you only a single object. However, if you all the way go from here to transaction, then go to generated by, okay, will that return you a set or a single object? Yeah, it's going to return you a set. Okay, it's going to return you a set. Yes. So you can navigate through maybe with multiple dots. Yeah.
So with the set, if it goes to one to many first, then you can expect a set, right? Or is it just if you're looking for a set of services?
Can you repeat your question?
On the one before, you said you're going from customer card to transaction to service, right?
Yeah.
You said that's going to return a set.
Yeah, it's going to return a set.
A set of services for each transaction. Is that what you're saying?
Yeah, it's a set of services for each transaction. Although this, like transactions is, service to transaction is one too many. However, there can be multiple services for a set of transactions. That set of transactions, they do not necessarily belong to the same service. Okay, that's why it returns a set of service.
Because one transaction could have many services.
No, one transaction can have only one service. Okay, but I mean, when you go from here to here, it's a whole bunch of. Okay, let me take this example. From customer card to the custom cards transactions. So you have a card. Your card transaction, some of them is your transaction with Delta. Some of them is your transaction with the gas station. Okay? So for those transactions with Delta, it may belong to a service. But for those transactions with the gas station, it will definitely belong to another service because basically those are services from different partner. Okay, that makes sense. We need to have a real world example.
This is a set of transactions.
Yeah, yeah. So anyway,
We say that one we only return one.
what's that?
You said from transactions to service, it will only return one.
Yeah, if your contact's here, and then you navigate to generated by, it's going to be returning only one of them. Okay. However, if you navigate through here to here to here, it's going to return you a set because of the example I just mentioned. So you have a card. I have a membership card. I use it in different company, but those transactions will belongs to different service. However, here, if our transaction is here, okay, means we're in some certain transaction. That transaction can only belong to one service. One transaction can only belong to one service. But if you have a lot of transactions, it may belong to different services. Okay. Good. Okay, right. The point is you can use these relations to navigate through different things. Okay, to reach different class. All right. Available services. All right. Okay, so that's how we define new attributes and new operations. So remember, if we want to define new operations, these operations have to be query operation, which doesn't change anything. It's just getting information, pour information out. Okay, like this. It doesn't change the state of the system. It just tell you what is the service provided by a golden level or silver level or something. Okay, that makes sense, right? So you can only define operation that doesn't change the state. Okay, like adding new operation with this define. All right, then let's talk about this more about invariance. We've done that a little bit. So invariance means it has to be true throughout the lifetime of the system. Okay. Okay. So it's a constraint that should be true for an object during its complete lifetime, as long as object is there. This should be true. And invariants often represent the rules that should hold for the real-life objects after which software objects are modeled. Let's look at the example. Okay. Example is like the age should be customer's age should be greater or equals to 18, something like that. So look at this customer. It actually has an age. context customer. So INV age greater equal to 18. Also, yeah, this is true. And also, what you can do is you can give a name of this for this invariance. That also work. You can name it like of age. Okay. Yeah, that's what we already done. And then let's see more complicated invariants. Yeah, that's invariance on the attributes. Okay. And also you can define this relations between two attributes. And yeah, if you look at this diagram here, some of the attributes is Boolean, okay, Boolean, string, integer, that's not a problem. But some of the attributes, they are the type you define. They are of the type, like here, data type. Let me show you this. Here, you define data type, data, which has different attributes on operation, and you're using this data, date, this type. So sometimes when your data structure, your own data structure, or your own class, okay, you use that as the type of one of your attributes, okay, like customer card. Look at custom card. It has an attribute called valid from and good through. Like the card on the card, you have a good through date. So that is of the type date. Date is not one of the basic types of the OCL. So, but it's defined here within this UML diagram. So you can use this. You can use this if you want to represent, put some invariants like constraints on this data. Let's see, what can we do? Like we want to make sure that valid from should be before the date of good through. Okay, before the date of good through. So the context here is the card, custom card. Now we want to put the invariant which make sure the valid from should be earlier than good through. Okay, remember this, we want to make sure valid from should be earlier than good through. Okay, now let's look at it. How can we write down this invariant? Valid from should be earlier than good through, given this context customer card, and also given this data type date. And also pay attention to here, the date actually has some of the operation here. Well, it's before and it's after, something like that. Okay, now how can we how can we use OCL to say we want valid from to be earlier than good through?
Context would be
Yeah, context is in customer card, yes.
customer card. And then you have define. Wait, you said good through couldn't be greater than.
Yeah, good. We want to make sure valid from is earlier than good through.
Okay, so then you just have customer card dot valid from is less than customer card dot.
Okay. So that's less than, right? You're using less than.
Yes,
Uh,
because valid from has to be less than good.
Yeah. So the logic is correct. You want to make sure it's less than. But however, those less than is compared to maybe integers, real numbers. However, here we have the type date. It's not an integer. It's not real.
So you'd have to do you have to call data.
Look at
for
here.
date.
We have this operation for the date. You see this is before. We can directly use that.
So you would say valid from.
Yeah, we can say self dot valid from dot is before, and between the brackets we put the good through. Yeah, so something like this. Self dot valid from is defined already defined by this date data type. Is before good through.
Then you would put the.
Yeah. Yeah, that's it. We don't have to put anything else. Or another way is self dot good through. Is after. I believe I saw this. Yeah, we have is after actually. It's after here. Is after valid from. Okay, so you can put self dot here or not. It doesn't matter actually.
So is date a Boolean?
Date. No, date is not Boolean.
Yeah.
Date is defined here. It's a data structure you define. Okay.
Okay.
It's not a basic data structure. It's not the basic data type. It's a data structure you define, like linked list, okay, array, queue. You can define all those data structure. So this data structure is called date. All right. All right. Let's keep it simple. So that's put invariance on the type of the attributes, and we can put invariance on associated objects. What do you know? What is an associated object? Okay, so like for example here, every card holder should be of age. Like what we define here should be of age 18 or above. So here. What we define is in customer, context customer, we define the age greater or equal to 18. Okay, and associated class means we reach the customer through its associated class, through those classes which has relations with the customer. For example, from the customer card. From the custom card, if we want to define the age, should be every customer's age should be greater or equal to 18. Then we can do what we can do. We want to make sure. Let me show you. For age should be greater or equal to 18. Okay, from customer card, let's see. Remember what we want to say. The age of every customer should be greater or equal to 18, and we are now doing it through the customer card. Then what do we do? We navigate to the customer, right? Because there's no age in the customer card at all. So we need to navigate to the customer from the customer card. Now, how do we do the navigation?
Customer dot age.
You don't have age. No, now you're in customer, right? Customer card. You're in customer card. Now you want to specify something of the customer.
So you do owner?
Yes, exactly. Owner. We just need to say owner. Or you can say self.owner. It doesn't matter. Owner or self.owner. Owner dot age. Yeah, I think. So owner is reaching the customer. Okay, customer has the attributes called age greater or equal to 18. Okay. Confused?
Why
Yeah.
can we use self instead of owner?
What's that?
Why do we have to use owner? Can we use self dot age?
Can we use
Self,
self.age?
yes.
Because now the context is customer card. We're in customer card. Customer card doesn't have any attributes called age. You find the age?
No.
It doesn't have any attributes called age. So you have to go here, go to the customer. So from custom card to customer, you have to navigate through its relations, which is owner. Then you can reach an attribute called age. Make sense? Okay, great. Alright, so that's the invariants. Now let's talk about using the association classes. Basically, we've used that more or less. We navigate through dot and access them, right? So loyalty program. Let me find another good example. Okay, now we want to say that the service level of each membership must be a service level known to the loyalty program for which the invariance so remember this, we have a service level from membership and service level from the loyalty program. Now we're trying to specify this thing. The service level of each membership must be a service level known to the loyalty program. Okay, we want them to be consistent. We want to have, for example, if the loyalty program has a silver level service, golden level service, we want the membership to have silver, golden, but we do not want the membership to have another program level, maybe called diamond level. Okay, we don't want that to happen. We want them to be consistent. All right. Now let me give you a context. So now we are using this context from the loyalty program. And how can we specify this invariance? Let me repeat the invariance. It's a service level of the member, of all the membership, should be the same service level of the loyalty program, known to the loyalty program. Okay, now we're in the context of loyalty program. So what do we do? We define that the service level of each membership must be a service level known to the loyalty program.
So then when you go to, and you're in a loyalty program.
Yeah, we're in the loyalty
So
program.
you would do levels.
Yes.
You do context loyalty program, and then I think invariance, and then you do levels dot name,
Mm-hmm.
and then you would have the arrow, and then available services dot service number.
Available services dot.
You're saying the service has to
No,
be-
not service. Member. We only look at member. Member, service level, and loyalty program. It's gonna happen between this three. Membership,
Oh, you're
service
going to
level.
membership.
Yeah. So,
Okay.
see, we have a membership of this relation between membership and service level, because membership can have different service level, right? Right. Every member has one service level, but one service level may be assigned to different membership. Okay, and then we have a relation between loyalty program and service level, which means in the loyalty program we provide many different level of service. We provide silver, golden. Now we want to make sure that all the membership has the service level that is known to the loyalty program. We do not want you come with a card called I am a diamond level member, but this kind of member doesn't exist in the loyalty program. We want to make sure that doesn't happen. Okay.
Would you do so? You wouldn't go to services. You just go to service level,
Yeah.
and then you would say name dot exists.
Yeah. Let me remind you one thing is we have a operation we have method for the set which is called includes or. Remember that?
Okay.
We mentioned that last week. Yeah. Includes or. Includes or basically it returns true if the subset is all included that set.
So you would do levels dot includes all. And then
Yeah, something like that. Levels includes all, and what is within that includes all?
Current level.
Current level. Okay. Yeah, that makes sense. Actually, current level, we're using current level, yes. But now we're in the context of loyalty program. Current level is the relation between membership and service level. You cannot reach current level through the loyalty program, right? Because we're in the context of loyalty program. Current level is not anything related to loyalty program, because current level is something only related to membership. Okay, let me put the answer out to save some time. So what we want to do is levels includes or. Actually, when we want to use this function of the set or function of any type, we actually use this arrow instead of dot, but similar. But includes or, then membership dot current level. Okay, so here from the loyalty program, we first navigate to this levels. From loyalty program there, we navigate to the levels. Level is the service level. It's a set of service level. Okay, we want to make sure this set includes all the memberships current level. Okay, so here, instead of specifying like every member, we use this class membership.current level, because every instance of the membership is generated from this class. So if we say this class.current level is included in this level, then we make sure every member's level is included in the program's level. Okay. Okay, we make sure no diamond level services there. All right. You can just listen to my explanation, because you can find the answer in this in this textbook, which is scanned here. It has been scanned already, so you don't have to. You can take note, but you do not need to write all these things down. Okay. All right. Membership. Let's try another thing. Okay, now let's define. Let's still use the define. Let's define a query operation in the context of membership. Let's go here. In the context of membership, let's define a query operation which use the ordinary association between membership and the service level, which is the current level. So let's define a function that get all the names, get the name of the membership's current level. Okay, we define option. we define a query operation which returns the name of the current level service of that membership, which means you are a member, you have you're a golden level or silver level. We want to define the operation here in membership, which returns your current, because there's no operation at all there in membership. Now we want to add an operation that returns the name of the service level. Just say it. You can say context is member, right? Membership class. Membership class. And we define an operation. We can call it anything, get name or get level name. Then we use the current level to give the name. Does it make sense? Okay, let's write it out. So the context is a membership. We're in the membership context, membership. Okay. Now we want to use define. To define an operation, we can call it get name or get level name. Okay. And then it should be a string because the name is string. And then it's okay. Does this make sense to you? We define a new operation of the type string, and this operation will return the current level name. Okay, it's like you have a card, and the staff is trying to check what level you are in. Okay, so you can just, from membership, you have this service level name. Okay, so it's going to be done by this operation. All right. Yeah, it's kind of weird, but let me give you another example and see if you can tell what does that mean. So if you have a computer, look at this diagram and tell me what is this. It's context membership. Context membership, okay? And now we're doing things like participants dot cards, which is a set. It includes self dot cards. What does that mean? Just this one, this part.
the customer card?
Every customer has a card.
Yes.
Every customer has a card has already been assured by this one-to-one relationship between the membership and the customer card. Yeah. So this actually means something else. So this just make sure that, okay, we have a membership there. Membership. The membership has a card, right? Membership has a card. Okay? Every membership has a membership card because it's one-to-one, right? Okay, based on that. So the membership, we go to participants. The membership has a whole bunch of customers there, which is we navigate through the customer to the customers through the participants. So the membership's customer. So the membership's customers cards. So of all these customers who participated in this membership, their cards should have the card of this membership.
When you say self.card, are you referring to membership?
Yeah,
Okay.
because we're in the context of membership, right? So when we say self.card, it's here, this card. So this basically saying all the customers. So the customers of this membership should have this membership card. Should have this membership card. Okay. Something like this. All right, let me stop here. I'll give you time to ask questions. Yeah, in order to have a better understanding for this thing. Okay, so which part actually confused you the most? Is it define or body, invariant, initiate? So we have go through a bunch of these operations in the OCL. Includes initiate. We initiate a number to attributes. We initiate the attributes with a number, or we initiate these attributes with a boolean. Okay, and also derived type. Yes, we use this dot stuff, and we return something. We give it to this either operations. We give it to this attributes. Okay, and then we have this body. You still remember what is the body? What are we trying to define with body? Query operation, right? Operation. And with this define, we define new attributes. Okay, we define new attributes or operation to a class. But this operation has to be query operation, which doesn't change any state. And then we learned for the invariance, which is it has to be true throughout the lifetime. So, and data type, we can use the data type we defined, right? And method inside, like we can use is before. Okay, and also, and logic important is we can navigate through this whole graph, this whole diagram. Like we can reach this service through the loyalty program by different ways. We can go through partners, delivered services, or we can do levels ordered available services. Okay. Will they return the same set? May or may not. Okay, it depends on the path you going through. If it's loyalty program, partners, and delivered services, it means or basically if you go this way, left way, or right way, in this case it will return the same. I think it will return the same. Yeah. However, let's find another example. Membership card to transactions. Account to transactions. That's the other thing. Okay, so for example, let's look at this membership class. Okay, if we want to go from membership to this transaction, okay, one way is to go all the way down from membership to account to transaction, which means for that membership, all its account, all the transactions belongs to that membership. But if you go all the way up, like membership to participants, then go to cards and transactions, it will return a bigger sets for all the participants. Okay, for all the participants. All right. Okay, so basically that's the logic there. Define invariants, and we navigate through the thing, and we use the dot to navigate through. When we're trying to use some method, we use the arrow. When we are navigating, we use this dot. Okay, so that's all I want to talk about today. And okay, thank you for coming today. Yeah, please read all this example again in your textbook. Okay.
Do you say this week is a review or